So we've been talking about multiplying radicals. We multiplied like a single radical by a single radical. We multiplied a single radical by a couple of radicals. And now we're looking at these. How many multiplications do you think you're going to have to do? Doesn't this look close to something like you already know how to do? Like if I said this, how many multiplications? 4. Same thing. Binomial times a binomial is 4 multiplications. Binomial times a binomial is 4 multiplications. So that's all you do. And then use your knowledge of multiplying radicals. So 4 root 3 times root 2. 4 root 6. 4 root 3 times minus 2 root 7. So it's going to be negative 21. And now go to the second term in the first set, multiplied by every term in the second set. So 3 root 5 times root 2, 3 root 10. And finally, 3 root 5 times minus 2 root 7 is going to be minus
6 root 35.
And just like we were doing before, check your radicals, see if you can take them exactly to simplify, or if you can break them down using the highest perfect square. Can you? Anything? Any of those radicals? No, none. That's as far as we can go. Four root 2 times root 7. 4 root 14. 4 root 2 times 5 root 14. 20 root 28. Minus 3 times root 7. 3 root 7. And minus 3 times 5 root 14.
Negative 15 root 14.
Well, I see like radicals, and I also see a radical that I can break down. So I won't do this just yet, but you should be able to see root 28 can be broken down to four and root 7 minus 3 root 7 minus 15 root 14. I can simplify this second term further. What's root 4?
2
Times 20.
40.
So that works out to 40 root 7. That is that. And I've got some like radicals that I can combine. I've got 4 root 14s and then negative 15 root 14s.
Negative 11 and 14 and 37 root 7.
That's 37 root 7. Yeah. Try the next one on your own. You should get a single number for an answer if you do everything correctly. You should get 1. What's root 2? 4. Root 2 times minus 1. Negative root 2. 1 times root 2, which means those cancel each other out. Positive 1 times negative 1. 4 is the same as, this is 2, minus 1 is 1. Whenever you have, do you notice something about these two binomials? Anything?
So same question, but different like operations or conjugate.
Right. Same terms, but opposite signs, right? We call these conjugates of each other, which we're going to have, what the? Conjugates. Yeah. So if you take any binomial, its conjugate will always be the same two terms, but the opposite sign. And it doesn't matter whether there's square roots in there, or x's, or y's, or b's, or whatever. So like b plus 1, b minus 1. Root 5 minus root 2, root 5 plus root 2. When you multiply two binomial radicals that are conjugates, the radicals will always disappear and you get a number, always. That's going to be important for our next lesson. What does it mean to square something? Times it by itself. Remember, it does not mean square this and square this. It means multiply by itself, parentheses and all, which means 4 multiplications. Again, 4 root 5 times 4 root 5. 16 root 25. Plus 4 root 5 times 3 root 3.
12 root 15.
12 root 15. Plus 3 root 3 times 4 root 5. 12 root 15 again. And finally, 3 root 3 times 3 root 3. 9 root 9. Look at our radicals. Look at the square roots. What can you do with this? It's 5. So 5 times 16
80.
is 80. Can't simplify these or take them exactly, so I just rewrite them. Root 9 times 9. And now I've got some terms I can collect. I can collect the numbers, 80 and 27 to make 107. 12 root 15 and 12 root 15 is 24 root 15. Remember, don't multiply those numbers in the radicals because we're combining them, we're adding them. Okay. And the last one is a little bit of a thinking problem. Okay. You are asked to find the area and perimeter of the inner square. So this white square. And the only thing you know about the problem is the side of the big square is 8, which means all of those are 8. And this is inscribed in the bigger square. Inscribed means the corners of the white square will touch the sides of the gray square. That's actually important. So what do I need to know to answer this question? What? Nothing? Like, what do you have to know how in order to find the area and perimeter of a square? answer the question I'm asking. What do you need to know to find the area and perimeter of a square? The side. Okay, so somehow I have to find the side. Now go to your a squared plus b squared Pythagorean thingy. Okay? Because this is inscribed in this, can you tell me this length? 4. Can you tell me this length? And remember, every square has all right angles. So if I focus on this square here, or sorry, this section down here, I can find the side using Pythagoras, or a squared plus b squared equals c squared. So a squared plus b squared equals c squared is the formula we use. Well, one side is 4, the other side is 4. I call the hypotenuse x. What's 4 squared and 4 squared?
16.
And 16, which is 32, thank you. So therefore, x is equal to the square root of 32. And remember, express answers as mixed radicals, okay? Or leave your answer in radical form. We don't go to decimal. We don't go to decimal with any of these. Unless you're asked to round your answer to something, then you go to decimal. Well, there's a couple ways you could do this. We can simplify this first and then find the area and perimeter. Or we could just leave this as it is, find the area and perimeter, and then simplify after. Both are going to get you the same answer. So I'm going to leave it. How do you find the perimeter of a square? Add up both sides, 4 times the side length, right? So it'd be 4 times root 32. Well, which is just 4 root 32. Can I simplify root 32 or take it exactly? Yeah, highest perfect square? 16. So this breaks down to 4 times root 16 times root 2. Well, root 16 becomes, and 4 times 4, I can multiply those together. 16 root 2. And units. Perimeter is just length, so centimeters. The area, well, the area of any square is the side length squared. So I'm going to do root 32 squared, or root 32 times root 32. Can you give me the answer without a calculator? Remember what I said whenever you multiply a square root by itself? Like what's square root 2 times square root 2? Which is? 2. So square root 2 times square root 2 is 2. What's square root 5 times square root 5? Square root 25, which is 5. So what's square root 32 times square root 32? 32. And it's centimeters squared. Or, I mean, you could have actually done 32 times 32 and then take the square root of that, and then you're going to get back to 32. Still works. Okay. Any questions? Okay, so like I said yesterday, All of exercise 1.3 should be done for Monday because we don't have class Thursday. And that's everything.